Okay, so this is your homework on solving radical equations for April 1st. At the top of your paper it says radical equation. We're going to fill in a couple blanks and I'm just going to talk through these. So an equation that has a variable in a radical or has a variable with a rational exponent, those are considered radical equations. So that means we either need to have a variable inside of a radical or a variable raised to a rational exponent. So either of those would work. And then below that it says to solve a radical equation, you would isolate, and I would underline the word isolate, the radical on one side of the equation, then raise both sides of the equation to the reciprocal power. Reciprocal is what goes into your blank. All right, so we'll go ahead and start our first problem, which you have at the top of your paper. So notice that you have some steps in capitalized letters there. So first it says to isolate the radical, and if you remember correctly, the word isolate means we have to get it by itself. So this is the radical right here, and we want to isolate it. We want to get it by itself. So that means we need to get rid of this 2 over here. Since the 2 is positive, I'm going to subtract it from both sides. So now I have the square root of 3x minus 2 is equal to 4. And then the next step says to undo the radical with the appropriate power. So the way to undo a square root is to square it. So if I square one side, I have to square the other side. And if I square this side, the square root and the square are going to cancel out, so I'm just left with 3x minus 2. Over here, 4 squared is 16. And then from this point, we're just going to solve the equation, just like you've done all along. So we would add 2 to both sides. 3x is equal to 18. Divide by 3. X is equal to 6. So we do have a restricted domain in this one that we want to make sure that we're just paying attention to because it's important. So because we're taking the square root of 3x minus 2, whatever we take the square root of has to be positive. So I know that 3x minus 2 needs to be greater than or equal to 0. So you've got sort of 2 options here. You can solve for x and then just make sure that x is within that domain, or if you want to, you can just plug in the 6. So is 3 times 6 minus 2 indeed bigger than or equal to 0? So 18 minus 2 is 16, which is bigger than or equal to 0, so this is our answer. So just one answer this time. So what I'd like you to do is pause the video and do A, B, C, and D, so just those 4 problems. And then if you turn it back on, or if you play it again, unpause the video, I'll kind of go through the steps for that. All right, so for letter A, in order to isolate the variable, we would first want to add 6 to both sides to get that radical by itself. I'm sorry, isolate the radical, not the variable. And then this is equal to 6. So then we would take each side squared. This is going to undo itself, so 5x plus 1 will equal 36. 5x will equal 35. X will equal 7, and I'll just double check. So I know that I'm taking the square root of 5x plus 1. I'll just do this in pink. So I know that 5x plus 1 has to be greater than or equal to 0. Again, you can solve for x and make sure that x is in our domain, or you can just plug it in. So I know that 5 times 7 plus 1 is bigger than or equal to 0. So 36 is bigger than or equal to 0, so this is our answer. For part B, this is a little bit different, so we're going to isolate the radical. So in this case, there's only the x inside the radical, so I need to get rid of the 1 first. We're going backwards from the order of operations, so 4 times the square root of x should equal 4. I'll divide each side by 4. The square root of x will equal 1. And then I want to square each side. So x is equal to 1. And I'll just double check. So inside the radical is just an x. So that x needs to be bigger than or equal to 0 in order to take the square root of it. And it turns out 1 is greater than or equal to 0. So our answer is just x equals 1. Part C, we just need to subtract 8 from each side. So the square root of 1 plus 3x should give you 4. And then we'll square each side. I'll do this in pink. So 1 plus 3x will give us 16. If I subtract 1, 3x is 15 and x is 5. If I divide by 3 on the last step, so we'll just double check. 1, I'll use blue here. 1 plus 3x, which is inside of our radical here, should be bigger than or equal to 0 so that we can take the square root of it. So if I plug this in, 1 plus 3 times 5 should be bigger than or equal to 0. So 16 is greater than or equal to 0, which I know is true. So x equals 5 is good. So last one here, and then we'll just move on to one more problem. So D I need to isolate, which means I need to get rid of this negative 5. So in order to get rid of it, I would add 5. So square root of 4x minus 2 equals 14. Square both sides. 4x minus 2 equals 196. And I'm going to add 2 to both sides. So I get 4x equals 198. When you divide both sides by 4, you should get that x equals 99 halves, or 49.5. So I'm just going to double check 4x minus 2 should be greater than or equal to 0. So if I plug this in, 4 times 99 halves minus 2, I don't actually need to go through that whole problem. I know that's definitely going to be bigger than or equal to 0. All right, so next problem. Number 2, we're going to practice some more of these in class tomorrow. But this is where we're using the reciprocal. So we mentioned that at the beginning, but we haven't actually used it yet. When you're taking the square root of something, I'm doing like the square root of x, that's the same thing as x to the 1/2 power, and then we squared it to undo it. So if you think about the exponents that we just used, 1/2 times 2 is the same as x to the 1st power. That's essentially what we want to do, but when we have an exponent different than a half, it's going to get a little bit more complicated, but it's the same exact concept. So I'll erase this just so that it's not distracting us. And we need to first isolate the part of the equation that's being taken to the reciprocal, to the rational exponent. So that means I need to get rid of this 2 right here. So I'm going to divide both sides by 2. So x minus 2 to the 2/3 is equal to 25. Okay, so now we need to deal with this 2/3 power. So we know from our notes from last week that that means that we're taking the cubed root of something to the 2nd power, which we just need to do the opposite of. So instead of thinking about what root we're taking, we're just going to use the opposite of, the reciprocal of 2/3. So the reciprocal of 2/3 would be 3/2, and this will make a little bit more sense once we actually go through with it in a second. So I'm going to take the left side to the 3/2, and just like before, whatever we do to the left side, we also need to do to the right side. So the point here is we've still got this x minus 2, but now it's to the 2/3 to the 3/2. So if you remember correctly, you would just multiply those together. So 2/3 times 3/2 gives us 6/6, which is just 1. That's what we wanted. We don't want to have any exponents there if we're trying to get this by itself. That was sort of the whole point of what we're doing, is to get rid of these exponents. So x minus 2 to the 1st power, which is what we wanted. And then 25 to the 3/2. Generally, when you get a problem like this, it's going to be something that you're able to solve. So the 2 tells us that we're taking the square root. You can put a little 2 there if you want to, but you don't need to, of 25, and then we're going to cube it. So over here, I've got x minus 2 is equal to, I know that the square root of 25 is 5, and I'm going to cube 5. So x minus 2 is equal to 125. And then x would equal 127. And that's our answer. So because this would be a cubed root, since the denominator is a 3 up here in the original equation, the cubed root, we can actually take the cubed root of a negative number. So x minus 2 doesn't necessarily need to be bigger than or equal to 0. But we can check this really quickly, and then we'll be done. Oops, some weird things going on there. So if we plug it into the original equation, 2 times 127 minus 2 to the 2/3 should give us 50. And I know that looks complicated, but it's not that bad. So 127 minus 2 is 125. We're going to take it to the 2/3. So that means we're taking the cubed root of 125 and we're squaring it, multiplying it by 2. So the cubed root of 125 is 5. 5 squared is 25. And 25 times 2 is 50. So we know that we got that correct because we just checked it. So you can label this your check step in your notes. And that's it. So we'll finish this tomorrow. Have a good night.